Hi, how are we doing? So today I'm going to look at solving trigonometric equations and look at the basic principles of how to solve a trigonometric equation. And I'm going to come back to this shortly. All right. So I'm going to start off with this simple one. So solve this. Now it may be that in the context of things you've had to solve something more complex and you've got down to this step. What this video intends to do is show you what to do when you get down to the final steps, when you want to work out the actual angle. So we've got down to sine x equals 0.5. And you need to do it in this interval here. The first thing I would recommend is you check your calculator mode. Okay. So, for example, here when you look at your calculator, you've got to make sure it's got an R for radians. So I'm just going to do that now. So angle units, radians, and I'm ready to go. Okay. So just check what mode you need your calculator to be in, and then you do the inverse sine of 0.5. Okay. So you do the inverse sine of 0.5. Now when you do that, obviously I know what it is. I'm just showing you what you do. You get your first answer, which is going to be pi over 6. It says 1/6 pi on the calculator display. And there's going to be more than one solution. What your calculator does is it gives you the most straightforward solution. Normally it's an acute angle closest to 0. Okay? And it's your job to work out what the other answers are. What you need to do is consider what is happening with the sine graph. And if you do A-level maths, you need to know what the graphs look like. Okay? So there's no way around that. Try not to think I can do this without the graph. You need to know what the graphs look like. All right. So here's the sine graph. Yeah. And I've just drawn it for one cycle. So the period is going to be 2 pi. What you're doing is just seeing where the graph meets the line y equals 0.5. So that's what you're doing when you're solving sine x equals 0.5. And it meets it here. So you can see on the graph, that's where pi over 6 would be. And if you continue this line, it's going to meet it again. And again, it will meet it infinitely in both directions, because the sine graph will do this forever in both directions. And so this horizontal line will meet the graph infinitely, an infinite amount of times. That's why you're given an interval in which to leave your answers, because you only want the answers between 0 and 2 pi. So this is the second answer we're looking for. So the sine graph, use the symmetry that between here and here, it goes up at the same rate as it comes back down again. Or in other words, from here to here is the same as here to here, but backwards. So this bit here of pi over 6, that distance will be the same as this distance here, also pi over 6. So what you'll do is you'll do pi subtract pi over 6. Okay? And your second solution will be 5 pi over 6. So you just type in your calculator pi subtract pi over 6 and get your second solution. Okay? That's a sine graph example. A cosine one. Okay? Similar thing, this time you'll do the inverse cosine of 0.5, still in radians mode, you'll notice, and the first answer your calculator gives you is pi over 3. And you've got to consider where that lies on the graph. So the cosine graph, same as the sine graph, except it's been translated, pi over 2 radians. It starts here, and it comes back down, and then up here, so that's one cycle of it. Okay, one period of the cosine graph between 0 and 2 pi. So again, you're looking to see where this horizontal line intersects with the graph, the cosine graph. So here's your first answer. And when I said earlier that your calculator gives you the most straightforward answer, well, it's giving you your answer closest to the origin normally. And it tries to give you a positive answer. Sometimes it doesn't, sometimes it gives you a negative answer. It's trying to give you the most easiest to work with answer as a first value. But this is the first value. And you're going to use that to work out what all the other possible solutions are. So here, the graph is going to cross again all the way over this part here. All right. This time the symmetry is that the graph from here to here is doing exactly the same as from here to here, but backwards. Okay? Exactly the same curve. So the way I look at it is that this gap here between 0 and the first answer, pi over 3, is the same as this gap here between 2 pi and your second answer. So that bit is the same as that bit there. So that's why you want to do 2 pi subtract your first answer. So 2 pi subtract your initial answer pi over 3 gives you your second answer. Now I'm going to do a tan graph example. Here we go. So solve tan x equals 1. Again, calculator, radians mode. Do the inverse tan, pi over 4. And then considering the tan graph. This is what the tan graph looks like. So you've got an answer here, here. This is the second answer you want. This time what you're going to use is the fact that the period of the graph is pi. So it does this shape every pi radians. Okay, I'll do it again. the simplest thing to do is just, when you've got your first answer, add on pi to get to that one. Because that's how the periodic function of the trigonometric graphs work. That added to pi gives you the next solution, added to pi gives you another solution. So I personally find the tan graph easiest to deal with, because you just got to work with adding pi to whatever your first answer was. So you get 5 pi over 4. Now I'm going to go back to this screen again. Okay. Maybe do a screenshot of this, because it might be very helpful for your notes. Okay. So with the sine graph, generally speaking, you've got your first answer somewhere here. If you do pi, subtract your first answer, you'll get your second one. Okay. With the cosine graph, your first answer here again, this time you do 2 pi, subtract your first answer, gives you another one. And with the tan graph, as soon as you get your first answer, just add on pi to get the next one. Okay. Next, I'm going to show you what to do once you've generated those two answers. Okay. So, that's not what I want. This is what I want. Suppose the interval is different, so between 0 and 4 pi. Okay. Well, can you do this for me? Maybe pause the video and work it out. You do the inverse sine of 0.6. I'm going to do that now. So inverse sine 0.6. So I'm getting 0.6435, 0.64. I'm going to round that to 3 significant figures. Okay, 644. That's not a nice looking 4, is it? You'll not be pleased with my 44 now. There we go. Remember what to do to get your second answer? You subtract that from pi radians. So the first thing to do is pi subtract that. And I get 2.498. That's be 2.50, isn't it, when I round it? Also 3 significant figures. Now, those are what I call the first two answers, the initial two pairs of solutions. Initial pair of solutions. How do you get all the rest? Well, the sine graph, of course, looks like this. I'm going to draw a small one like that. It's then going to repeat itself, isn't it? It's going to do another one of those. Okay, here we go again. And it's going to do another one. And it's going to do another one. Okay. So here you've got up to 2 pi, and then when I did another one, it's up to 4 pi, and then when I did another one, 6 pi, 8 pi, and so on. Okay. All you do is to get from these two initial answers, you add on 2 pi to each of them, and you get to those two. 2 pi to get to another 2, 2 pi to get to another 2. So to generate more answers, you just keep on adding 2 pi to each one of these. Okay? Because I've got this one still in my calculator display, I'm going to add 2 pi to that. First of all, I'm going to write it down and leave a gap, so that'll be 8.78, 3 significant figures. To get this one, I'm going to go back to the original I had, which was inverse sine of 0.6, okay, 0.6435, add to that 2 pi, and 6.92, 9266, so 6.93. Okay. If I needed more, I'll just keep on adding 2 pi. If I needed answers that were negative, so suppose the interval is between negative 2 pi and 0, for example, I would just do those two as my initial answers again, and then subtract 2 pi. So I'm always looking to see what are the first two answers I can get in a single period of the graph, and then add or subtract 2 pi from those. I'll do another one for you. Maybe pause the video and have a go at this yourself. So it's cosine theta is 0.3. Okay? This time between negative 2 pi and 2 pi. So your first answer, did you pause the video or are you just continuing to look? It's up to you. I don't mind either way. So inverse cosine of 0.3, I get 1.266, so I'll call it 1.27, all 3 significant figures. The next answer, remember what to do? You do 2 pi minus that one. So 5.017, so 5.02. Now, what about the next answers? Same again, exactly the same again as what we did in the previous one. So that's one cycle of it, up to 2 pi. And then another cycle takes us up to 4 pi. Going backwards to negative 2 pi. My line's a bit wobbly there. Okay. So once I've got two initial answers, like here and here, all I need to do is add 2 pi to get these two, another 2 pi to get another 2, or subtract 2 pi to get this one and this one. So I've got this one here on my calculator display, which is 5.02, because it's already there. I'm going to subtract 2 pi, and it gives me negative 1.27, and I'm going to do this one, subtract 2 pi, save you got time, it's negative 5.02. All three significant figures, by the way. Okay with that? Alright, before we go to the next one, just look at this graph. How do I draw it nicely? It's a symmetrical curve, the cosine graph. Okay, what that means is that value is the same as that value but negative. Okay, so that value 1.27, that value negative 1.27. This value here 5.02, that value negative 5. It's a nice looking graph because it's symmetrical about the y-axis. Okay, so that's a tick for you. If you're doing the inverse cosine, when you get a positive answer, just make it negative. That's also going to be an answer as well. If you don't remember that, just subtracting 2 pi will always give it to you. Last one, with the tan graph. So this time the interval between 0 and 3 pi. So first answer, again, maybe you pause the video and try it yourself. So inverse tan of 2, 1.107, so I'm going to call it 1.11. Now what to do to get the next one? Add on pi, so add pi to that. 4.25. Now to get some more, just keep on adding pi. Just keep on adding pi, right? So up to 3 pi, basically it's going to do this again, okay? And it will do this again, there'll be an asymptote there. You see it crosses the x-axis at 0 pi, 2 pi, 3 pi, 4 pi, 5 pi. So I'll get another one of those, add on pi again, 7.39. Now how do you know if you've gone too far? Okay, well I'll show you. Suppose I didn't know what I was doing, okay, or I just forgot, or in the exam I'm in a state of panic, or I just want to try and be thorough. Now let's just see if I add on another pi to that. I'm going to add another pi to this. Okay, all right, 10.5. How do I check whether or not I've gone too far? Well, from the interval that's been given, it's between 0 and 3 pi. Okay, well, I'm going to work out what 3 pi is as a decimal. It's 9.4 something. Doesn't matter what the rest of the number is, 9.4 something. You can see these numbers here, they're all in that interval. Okay, they're all between 0 and 9.4 something. This one isn't. It's beyond. So therefore I don't need it. I don't need to include it. So it's just those answers there. Again, all to 3 significant figures. Okay. I'm hoping you found that useful. Okay. Remember, this is just the beginning of trigonometry. You need to know how to do this bit here, because for most of you this will be the final steps of a more complex question. Okay. Right, thanks for tuning in, and I hope to see you again soon.